Okay, today I'm going to talk to you about distance time graphs. Now this is the second video that I've made about distance time graphs because this video shows you a few more complex things that you can do with distance time graphs. So for the more basic stuff, please watch the other video. So just a little reminder first of all, along the x-axis we always have time and on the y-axis we always have distance. So we're going to have a look at something slightly different this time. So I'm going to make it look a little bit more like this. Okay, and then up to there, and then like this. Okay. Now, this is different from the graph I drew in the first video because we've got these curves instead. And whenever we've got a curve, it tells us something different. Now, when we have an upwards curve like this, the object that's moving is accelerating. We have acceleration. That means it's getting faster because as more time passes, the amount of distance covered increases with each second. So if we have an upwards curve like this, it shows acceleration. Just like with the previous video, whenever we have a flat horizontal line like this in a distance time graph, it shows that the object is stationary. That means staying still. I can tell this because as time passes, we are not going any further. So it's staying at 3 meters in total. It's not going up, not getting further, so it's stationary. Now this point here, the object starts moving again now, but when we have a line like this, it shows deceleration. That means getting slower. As we can see here, it starts off quite steep, so quite quickly, and as it goes on, the amount, as each second passes, we're going decreasing amounts of distance every single time. So if we have a curve like this, we have deceleration, which means getting slower. So what we can actually do with these curves is there's a way to find the speed at a particular point. So let's say, for example, I was trying to find the speed of this moving object at 8 seconds. Now it's really difficult to do that. If it's a straight line, it's quite easy to find the tangent because all I need to do is find my distance and my time, which is nice and easy if it's a straight line. However, if there's a curve, I need to do something which is called drawing a tangent. So let's say I'm trying to find how fast this object is going at 8 seconds. What I need to do is I need to go up to my line where 8 seconds is, so at that point there, and I have to draw a straight line as best I can. I have to draw a straight line that shows the speed at that particular point, the gradient at that particular point, okay? It's quite difficult to do, but I think I've managed it there, okay? So what I then need to do is I need to make a right angle triangle using that line. So it's going to look a bit like this. So what I've done is I've made a right angle triangle. Now, you can make that triangle as big or as small as you want. I suggest we don't make it too small because then it makes the measurements less accurate. So what you normally like to do is make them a little bit bigger like this. It's also good if you can to try and use whole numbers. So try and kind of, rather than doing it at 3.2, try and get it exactly 3, just so it makes your maths a little bit easier. But they should work. It doesn't matter if it is 3.5 or 3.2, that will work as well. So what I'm trying to do now is, to recap, is I'm trying to find the speed of this object at exactly 8 seconds. I've drawn my tangent, I've made my right angle triangle, so now I need to find the gradient of that line. And to find the gradient of that line, I need to do speed equals distance over time. That should be a D. Speed equals distance over time. So my distance travelled here, let's have a look. Okay, so that, if I just look over here, I think that distance is around 7.5. And so to find this distance it's travelled is 7.5 take away 3, because I'm looking at this distance here. I want to find this part here. So 7.5 take away 3 is 4.5 metres. So that there is 4.5 metres. Now also, I need to find my speed. I need to do distance divided by time. So my time is going to be between here and here. So my time is going to be between 10 seconds, or 6 seconds and 10 seconds. So it's 4 seconds in total. So at that point, it was traveling to find the speed, I need to do 4.5, my distance, divided by my time. So I need to do 4.5 divided by 4, which equals 1.125 meters per second. So the very final thing I'm going to show you how to do is just find the average speed of this whole journey. So to find the average speed of the whole journey, all we need to do is find your final distance, which is 7 meters, divide it by your time, which is 10 seconds. So this one is 0.7 meters per second. Because what we've done is we've just found the average speed for this whole journey. So the only things we're interested in is our final distance and the amount of time the whole journey took. So that is how to do slightly more complex things with distance time graphs. Thank you.